Cool. So let's deal with the 67th question. If magnitude of A is less than 1 and magnitude of B is less than 1, then the sum of the series 1 plus 1 plus A into B plus 1 plus A squared into B squared so on is, and this is like an infinite series. Okay, fine. So the general term of this series, that is given by 1 plus A squared all the way till A power R minus 1, and this complete thing times B power R minus 1. Yeah, I think that's correct. So it's supposed to be A power R minus 1 upon A minus 1. In fact, I should write it like this. 1 minus A power R upon 1 minus A into B power R minus 1, which can be written as B power R minus 1 upon 1 minus A minus A times AB power R minus 1 upon 1 minus A. So that's our TR in that case. So now if we want to sum this up, okay, cool. So now we want to sum this from R equals to 1 to R equals to infinity. Okay, so the formula is given by A upon 1 minus R, where A is the first term. You can see these are like two different sums over there. So sum from 1 to infinity, that is going to be, first of all, I will take this 1 minus A common. So 1 upon 1 minus A common. The remaining stuff is B power R minus 1. So the first term, that's just 1, and the difference is B, so 1 minus B, minus of the first term is A, the difference is AB, so 1 minus AB over there. Okay, so that should work, right? So the sum of B power R minus 1 from 1 to infinity, that's this thing. Then for A into AB power R minus 1, that's this thing, and then you have this common. Okay, so that's supposed to be 1 upon 1 minus A. Let's simplify this. So 1 minus AB minus 1 plus AB upon 1 minus B into 1 minus AB. So this cancels. So it's supposed to be minus A over there. Okay, and you can see this is just 1 minus A over there, so that cancels with this guy. So it's supposed to be 1 upon 1 minus B into 1 minus AB, which is, where is that option? So this is over there, 1 minus B and 1 minus AB. Okay, so let's move on to the next question. So so A 1 by B C and 1 by P Q and 1 by R, these form two arithmetic progressions of the same common difference. Okay, then A, Q and C are in AP. If fine, so A, Q and C are in AP, that means that Q is equals to A plus C upon 2. But in fact 1 by B is also equal to A plus C upon 2. So that implies that 1 by B has to be the same thing as Q. Okay, so that's nice. But then you also have that the difference in these two APs are the same. So that pretty much tells me that Q minus A is the same thing as Q minus 1 upon P, right? Over here, this Q, it should be written as 1 upon B first and then as Q, but you get the idea that Q minus A is the same thing as Q minus 1 upon P. So that tells me A has to be 1 by P, and similarly you can prove that C has to be 1 upon R. Okay, cool. So in fact the first term of this AP is the same thing as the first term of that AP, and similarly for second and third terms. Okay, so what do we know then? We know that 1 by P, 1 by B and 1 by R are in a AP. Okay, cool. So that was easy. Okay, let's move on. So let alpha beta belong to real numbers if alpha times beta square be the roots of this quadratic equation, x square minus px plus 1 equals to 0. That means that alpha times beta square is equals to 1, and alpha square and beta be the roots of the equation x squared minus qx plus 8 equals to 0. So alpha squared times beta has to be equal to 8. That's nice. And these are like real numbers, so that gives me like alpha beta complete cube is equals to 8, which means that alpha beta is just 2. Okay, so now we can divide alpha beta squared by that thing, so that gives me beta equals to 1 by 2, and in that case alpha will be so alpha will be 4. Okay, cool. So now you got this thing that beta is 1 by 2 and alpha is 4. Okay, fine. So next we might want to find out the values of P and Q in that case. Okay, fine. So where is it? Okay, so alpha plus beta squared is p, which is also equal to alpha is 1 by 4. No, alpha is 4, sorry. So alpha is 4 plus 1 by 4, which has to be 17 upon 4. So p is 17 by 4. Okay, that is p. And what is q? Q is alpha squared plus beta. Right, so that has to be equal to alpha squared is just 16 plus 1 by 2, which is 33 by 2. Right, so that's q. So now we know the values of p and q, which is 17 by 4 and 33 by 2. So the next thing is finding the arithmetic mean. That has to be 17 by 4 plus 33 by 2 upon 2. That's supposed to be equal to 17 by 4 plus 66 by 4. So that has to be 83 upon 8 in that case. Fine. And this is supposed to be equal to r by 8. So what's the value of r? It's just 83. There you go. That was easy. So let's move on. If x, y, z are real and you have this equation 4x squared plus 9y squared plus 16z squared minus 6xy minus 12yz minus 8zx is equals to 0. Okay, so the first thing you see is 4x squared can be written as 2x complete square. Similarly, 9y squared and 16z squared can be written as 3y complete squared and 4z complete square, and then 6xy. It looks like it's the same thing as 2x into 3y, and similarly for the other terms, right? So it's like 4z into 3y, then you have 4z into 2x. That's supposed to be equal to 0. Then x, y, and z are in. So let's make a substitution. I will call 2x to be a, 3y to be b, and I will call 4z to be c. So that gives me a squared plus b squared plus c squared minus ab minus bc minus ac is equals to 0. So if I multiply this by 2, that will give me a squared minus ab plus b squared. I multiply this equation by 2 and rearranging this, plus b squared minus bc plus c squared plus c squared minus ac plus a squared. Okay, that has to be equal to 0. Right, so a squared plus a squared, 2a squared. Over here you got 2b squared, and oh, so it's supposed to be 2 over there as well. Okay, so let's multiply this by equation by 2 and got this equation. And now I can once again rearrange this. In fact, I can write this a minus c complete. Okay, a minus b complete squared plus b minus c complete squared plus c minus a complete squared is equals to 0. Okay, but because these are real numbers, because x, y, z are real numbers, so that means that all of these have to be 0 in that case. So I have a is equals to b is equals to c, which means that what was a? A was 2x is equals to 3y is equals to 4z, which is equal to k for some value of k. Okay, so that gives me x is equals to k upon 2, y is equals to k upon 3, and z equals to k upon 4. So if I take the reciprocal, I will get 1 upon x equals to 2 upon k, 1 upon y equals to 3 upon k, and 1 upon z equals to 4 upon k. And you can clearly see that these are in harmonic progression, right? X, y, z are in a harmonic progression because the reciprocals are in arithmetic progression. So there we go. Okay, that's nice. So x, y, z are in HP. The next question is let A1, A2 all the way till A10 be in AP and H1, H2 all the way till H10 be in HP. If A1 is equals to H1 is equals to 2 and A10 equals to H10 equals to 3, then A4, H7 is. Okay. Right. A1 is equals to H1 equals to 2 and A10 equals to H10 equals to 3. Okay, so I'm getting the thing now. So we can in fact compute the values of A4 and H7, but I don't want to do that. Okay, so what can we do? So let's look at it like this. So we can say that 2, A2, A3 all the way till A9, and well, A9 is just 3, and 1 by 2, A2, A3, A9, and 1 by 3, in fact, sorry, this is not supposed to be like that, then 1 upon H2, 1 upon H3, all the way to the 1 upon H9. These two are in fact APs. Okay, these two are APs, and in fact they have the same common difference, so that's another plus point. Okay, and we are supposed to find A4H7. Yes, so A4H7. Now they don't have the same common difference because it's like 1 by 2 and 1 by 3, so the difference is changed, but whatever. So what we can do is that we can write A4 as, first of all, we'll just find the difference in fact. So for the AP, I mean the original AP, I will write difference as small d, and for the harmonic progression I will write it as capital D. So that has to be equal to, well, how many numbers are over here? So 2 to 9, there are 8 numbers, so you make 8 steps but plus 1 step, so 9 steps. So 3 minus 2 upon 9, and capital D, which is the difference of this thing, that has to be 1 by 3 minus 1 by 2 upon 9. Okay, so that gives me A4, just 1 by 9 over there. This is actually equal to what is this thing, negative 1 by 6 into 9, something like that. Fine. Yeah, so A4, that will be equal to 2 plus 2 plus, wait, what? A4 will be equal to so you got 2, 3, 4, so the jump is of 3, so 3 times the difference, which is 3 upon 9, so that has to be 2 plus 1 upon 3, which is nothing but 7 upon 2. Okay, that's nice. And then 1 upon H7, that has to be equal to 1 by 3 minus 9, 8 and 7, 3 jumps, so 3 times this difference, that has to be equal to 1 by 3 plus 1 upon 6 into 9. Okay, that's nice. So that has to be equal to, you got a 2 and a 9, so 18 plus 1, which is 19 upon 6 into 9, right, which is just 54. So it's 19 upon 54. So H7 is in fact 54 upon 19, so our answer will be 54 upon 19 into 7 upon 2, something like that. Yeah, doesn't look correct. So what went wrong? Got 18, then got 19 over there, right? 7 upon what's the problem? Why is this not working? Right, so 1 by 3, then 9, 8 and 7, it should work. We got 3 times the difference, which is yeah, it's supposed to be negative 1 by 6, so yeah, that works. So 19 upon 54, that should work. Why am I not getting an integer answer in that case? I don't know. So that's 1 by 7, it's like 54 by 19. I don't know. Then A4 at 7 is that's weird. A1 is equals to H1 equals to 2. Okay, fine, these are in an AP, pretty obvious. And H10 is 3. Right, so the difference for the AP is, right, so you got 2 to 9, there are 8 numbers, so there are 9 jumps in total. Over here also there are just 9 jumps. Right, so what went wrong? But 1 by 3 minus 3 times the difference, which is 1 by 3. Oh, minus, sorry, so minus 3 times the difference, which means it has to be 2 into 9 in that case. Yes, so that will turn out to be 6 plus 1, which is 7. 7 upon 18. Okay, something like 7 upon 18. So instead of 54 upon 19, I will get 18 upon 7 over there. This cancels, you just get 9. So wait, 9? That's still not what we wanted. Right. Minus 3 times. What is happening? Why am I not getting an answer? This has to be 7 upon 3, right? So 2 into 9, that's be 18. So 18 upon 7 and then 7 upon 2 looks correct, right? No way. 987, that has to be 3 jumps, no problem. Yes, it should be correct, but then what's wrong? What is not correct in that case? No, it should be 9. Then this thing should turn out to be 9, right? 18 upon 2. I don't know, I'm making some kind of mistake over there. Okay, so I will do this question the last, because maybe I'm making some mistake which I'm not able to see. Whatever. So let's move on. So if a, x and b are in arithmetic progression, and a, y and b are in a geometric progression, and a, z and b are in a harmonic progression such that x equals to 9z and a and b are positive numbers, then okay, so x equals to 9z. Fine. So what is x? X is just a plus b upon 2. And what is z? Z is 2ab upon a plus b, right? So that gives me a plus b squared, which is a squared plus 2ab plus b squared. That has to be equal to 36ab. Okay, fine. So a squared, wait, this is weird. Right, so x equals to 9z. That's what we did got, right? Yes, x has equal to 9z. Okay, fine. We'll just see what happens. So then a squared minus 30. What is this thing? 34 ab plus b squared is equals to 0. There are no solutions to this thing in any ways, but okay, no problem. So what do we do now? Then magnitude of y equals to 3z, x equals to 3 times the magnitude of y, 2y equals to x plus z. Okay, there are a lot of things which are happening. So x equals to 3 times the magnitude of y. Maybe yes, maybe that might work. So sorry for that. So we know there's a property of arithmetic mean, geometric mean and harmonic mean, that g squared equals to a times h for any two numbers a and b. So over here we are just told that the geometric mean is y squared and the arithmetic mean is x, and this is like z. Okay, cool. And x is in fact equal to 9z, so I can write z as x upon 9, so this will be x squared upon 9. So x squared equals to 3y complete squared, so that gives me x has to be equal to mod of y. Yeah, that looks good. In fact, y is not the geometric mean, but plus or minus the geometric mean. Okay, that's nice. So x has to be equal to mod, 3 times mod y. Yeah, that's correct. So x equals to 3 times mod y. That should be our answer. Let's move on. The sum to 50 terms of the series 3 upon 1 squared plus 5 upon 1 squared plus 2 squared plus 7 upon 1 squared plus 2 squared plus 3 squared and so on. Okay, cool. So what's the general term of the numerator? That's supposed to be 2r plus 1, right? The general term of the denominator, that's just that's just 1 squared plus 2 squared all the way to r squared. So that has to be r into r plus 1 into 2r plus 1 upon 6. So that cancels. So just got 6 upon r into r plus 1. So that's the general term of this sequence, which is nothing but 6 upon r minus 6 upon r plus 1. Okay, cool. So now what do we want to do? We want to sum this to 50 terms. So our sum till 50, okay, starting from r equals to 1 of our general term, that will be 6 upon 1, and every other term in the middle portion that will get cancelled because it's a telescoping series, and you will directly have minus 6 upon 51, right? That works. Okay, cool. So 6 upon 1 minus 6 upon 51, yeah, so 6 into 50 upon 51, which is 300 upon 51, right? That's our answer. Okay, so let's see if that's the correct answer. So 300 upon 51, that's what we got. For some reason that's just not correct. Why do they keep doing it? Oh, maybe we can actually reduce this further. So this can be reduced as 100 upon 17. Yes. So 100 upon 17, that's the correct answer. Okay, the harmonic mean of the roots of the equation 5 plus square root 2 into x squared minus 4 plus square root 5 into x plus 8 plus 2 square root 5 equals to 0. Oh, okay, is the harmonic mean of the roots of this equation. So the harmonic mean is nothing but 2ab upon a plus b. Yes, we know how to find ab. In fact, because these are the roots, I should say it's actually 2 alpha beta upon alpha plus beta. We know what alpha beta is. It is 2 into 8 plus 2 root 5 upon 5 plus square root 2. And then alpha plus beta, that's just 4 plus square root 5 upon 5 plus square root 2. So in fact, this factor doesn't make any difference. So that's gone. So that has to be equal to this is like 4 into 4 plus square root 5 upon 4 plus square root 5. So this cancels, you just get 4. That's it. That's the answer. 4 is the answer. Okay.